Alright, so in this problem I have 222 to the power of 3x plus 222 to the power of x is equal to 222. So to start, I'm going to rewrite 222 to the power of 3x as 222 to the power of x to the power of 3. Because if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So now I have this plus 222 to the power of x is equal to 222. Now I'm going to let 222 to the power of x equal to the variable y. So now I have y to the power of 3 plus y is equal to 222. And if I subtract 222 on both sides, these two cancel out, and I get y to the power of 3 plus y minus 222 is equal to 0. Now I'm going to rewrite 222 as 6 times 37. And I'm going to rewrite y as negative 36y plus 37y. So now, from y to the power of 3 minus 36y, I'm going to factor out y, so I get y times y squared minus 36, plus, from 37y minus 6 times 37, I'm going to factor out 37, so I get 37 times y minus 6 is equal to 0. And y squared minus 36, that's going to equal y plus 6 times y minus 6. Now, if I factor out y minus 6, I get y minus 6 times y plus 6 plus 37. And this simplifies to y minus 6 times y squared plus 6y plus 37 is equal to 0. So now this gives me y minus 6 equals 0 and y squared plus 6y plus 37 is equal to 0. So for y minus 6 equals 0, y is equal to 6. And for y squared plus 6y plus 37 equals 0, there's actually no solution, because if you plug this into the quadratic formula, you get the square root of a negative number. So y equals 6 is my only solution for y. And remember how we let 222 to the power of x equal y. This means that 222 to the power of x is equal to 6. If I take the log on both sides, if I have something in the form log a to the power of b, I can move b to the front, so it's going to equal b times log a. So I can move x to the front here, and I get x is equal to log 6 over log 222. Alright, so in this problem, I have x to the power of 3 plus x equals 10. So I'm going to first start by subtracting 10 on both sides. So now I have x to the power of 3 plus x minus 10 is equal to 0. Now I'm going to rewrite negative 10 as negative 8 minus 2. And negative 8, this is the same thing as negative 2 to the power of 3 minus 2. So now I'm going to change the order real quick. I'm going to rewrite this as x to the power of 3 minus 2 to the power of 3 plus x minus 2 is equal to 0. And if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, this is going to change to x minus 2 times x squared plus 2x plus 2 squared, which is 4. This is equal to 0. Now, this gives me two equations. I have x minus 2 is equal to 0, and I have x squared plus 2x plus 4. And actually before that, remember how we have this plus x minus 2 is equal to 0. So now if I factor out x minus 2, I get x minus 2 times x squared plus 2x plus 4 plus 1 is equal to 0. Now, I have x minus 2 is equal to 0, and I have x squared plus 2x plus 5 is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2, so that's one solution. And for x squared plus 2x plus 5 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 2, and c is 5. So I have negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 5, all over 2 times 1. And now this is equal to negative 2 plus or minus the square root of 4 minus 20, which is negative 16 over 2, which is equal to negative 2 plus or minus the square root of 16i over 2, which is negative 2 plus or minus 4i over 2, which is negative 1 plus or minus 2i. So these are my three solutions to this problem. Alright, so in this problem, I have 9 to the power of m minus 9 to the power of n is equal to 648. So based on first glance, we can tell that m is greater than n because the result is a positive number and the bases are the same. So 9 to the power of m minus 9 to the power of n, this is a positive number, meaning 9 to the power of m is greater than 9 to the power of n, and m is greater than n. So now that we know this, we can say that m is equal to n plus some number k. And now I'm going to replace m with n plus k. So now I have 9 to the power of n plus k minus 9 to the power of n is equal to 648. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 9 to the power of n plus k, that's going to equal 9 to the power of n times 9 to the power of k. Now I have this minus 9 to the power of n is equal to 648. Now, if I factor out 9 to the power of n, I get 9 to the power of n times 9 to the power of k minus 1 is equal to 648. And 648, I can rewrite as 81 times 8. So now I have 9 to the power of n times 9 to the power of k minus 1 is equal to 81 times 8. Now, 9 to the power of any number, that's going to be odd, right? 9 to the power of any number is odd. And 9 to the power of any number is odd, but an odd number minus 1 is going to be an even number. So 9 to the power of n is odd, and 9 to the power of k minus 1, that's going to be even. So 81 is odd, and 8 is even. And notice how we have something in the form a number times another number is equal to another number times another number. And it's an odd number times an even number is equal to an odd number times an even number. Meaning we can set the odd numbers equal to each other and the even numbers equal to each other. So now I have 9 to the power of n is equal to 81, and I have 9 to the power of k minus 1 is equal to 8. So for 9 to the power of n equals 81, n is obviously equal to 2 because 9 to the power of 2 is equal to 81. And for 9 to the power of k minus 1 is equal to 8, this is a simple equation. I'm going to first start by adding 1 on both sides. So I have 9 to the power of k is equal to 9. And 9 to the power of what is equal to itself? 1. So k is equal to 1. Now remember how we set m equal to n plus k, meaning m is equal to n, which is 2, plus k, which is 1. So m is equal to 3. So n is equal to 2, and m is equal to 3. These are my solutions for this equation.